I always get questions about 47 and trying to put this in the calculator. So I've got it preloaded. Let me go ahead and show you what it's going to look like. There's our equation. Before I graph it, let me show you the table because we kind of have a sense of how this is going to go down. Now I used x instead of n, but n is a countable number usually. So really it should be. You do 1, 2, 3, and so on. So that's one place the calculator is getting bogged down. Let's pull up the table and see if we can get a sense of what we're supposed to see and then what we're going to see. So if we graphed what's on this table, we're kind of seeing an alternating sequence going on. We got at 1 we're at 12, at 2 we're at -9, 3 we're at 6.75, 4, 5, -5. It's almost like cutting in half each time as you go across. So that you should kind of see this thing that almost looks like two parts converging if you plot at these points. So let's look at the graph and see what we're actually getting from the calculator. Now I got lucky, I got 2 dots. And I don't know if you can see them on the camera, but there are 2 dots there. And that's honestly better than a lot of attempts I've made. So I don't want to bog down too much with what the calculator is doing, but domain to a function means something. And to the calculator, when you give it a window, in this case -10 to 10, I don't know the exact count, but the calculator knows how many pixels there are across the screen in each row. And it basically takes that 20-unit window from -10 to +10, divides it by how many pixels there are, and then each pixel represents a certain length of distance. And I don't know how it assigns them specifically. It probably picks like a midpoint or something. But hopefully what you're gathering here is that these pixels don't lie on nice countable numbers very often. They're usually some kind of decimal number. And of course it plugs those decimal numbers into the function to see what comes out. So it's pretty likely the x values that go in here are coming out to some pretty tedious decimal numbers. So let's think about what that's going to mean in terms of trying this. Now again, if you're going to do this by hand, you're plugging in 1, you're plugging in 2, you're plugging in 3, and so on. You're plugging in countable numbers. But the calculator, again, it's just plugging in whatever decimal it thinks should go in for that pixel. So let's see what would happen if n was 3/2. All right, well, if n was 3/2, then we're going to be taking -0.75 and raising it to the 1/2 power, which is the square root of -0.75. Now we know that that is a complex number, but that's not going to show up in our real plane. So it's not going to show up in the calculator. And if you start trying more and more decimal, or -0.75 to different decimals, you'll start to see that it's pretty unlikely you're going to get a real answer out. Every once in a while, when you take something like a 3rd root or a 5th root, you'll get lucky and you'll get a point out. But most decimals, and we don't really want to get into what a irrational root technically is, like if I raise this to the square root of 2 or something, I mean, it's getting pretty tedious, but just trust the calculator, it's not real, okay? So that's why we're not seeing much happen on here. We don't really want the calculator doing what it's typically doing in function mode, which is what I just said. It assigns each pixel a decimal value, and it plugs it into the function and sees what you get out. We want this thing just going through plugging in countable numbers. So I'm going to expand your world a little bit here. If you go to the mode button, right beside second, and you've lived your life in function mode up till now. Calculator has 4 modes it can do, and we're actually going to look at all 4 of these over the next couple chapters here. So I'm going to come down to the function mode, and I'm going to go on over to sequence, because that's what I'm trying to grab, it's a sequence. All right. Now, your variable button, up until this point in your life, you probably just call it the X button. A lot of you have noticed these things and asked me questions throughout the year about, hey, there's an N there, can I use that? Or there's a T, what's that for? So each one of those variables corresponds to one of these modes. And they're in order, there's 4 of them. You'll see what parametric and polar are in chapter 9, but sequence mode is at the very end, that's N. And that seems pretty good because that's what the book had for the variable was N, and N's a countable number here. So that's starting to kind of line up. So I'm going to go to y equals, and now it's going to look really different. So this is your actual function, where it says u of n. I know that seems kind of weird, but that's the notation. There's our function we're trying to graph. Above here it says n minimum. That's hopefully pretty straightforward. That's the minimum value of n, what you want to start with. And n is going to be a countable number because we're in a sequence mode. That's how it works. So typically we start with 1. Sometimes n starts at 0. You can really start anywhere you want, but it defaults to 1. So if you ever need to change it, that's where you would do it. And this is just your next function, your next function. So each one has a kind of a pair of things, starting n value and the actual function. That should be good to go. So I'm going to hit graph. And now we're starting to get a picture of what I hope we expected to see as we looked at that window, or the table earlier. I'm going to go out a little bit further. So, not zoom, on window. And it looks a little different, but it's basically the same thing. We are getting values by plugging in n values. So you got your n value list of what's going to be plugged in. Plot start, plot step, this is just where do we begin, how much do we count by each time. We want our n's to count by 1. Here's your x min, this is all your normal stuff, x minimum, or x and y window settings. All right, I want to go further to the right, so I'm looking down for x max, and I'm going to go 20. Let's see what this looks like. All right, it's almost like a zipper coming together. So what we're getting, it's an alternating sequence. It's jumping back and forth, but it is closing in on end result. Looks like it's probably closing in on 0 most likely. This will be kind of something you dig into a lot more with calculus, but this is what we call a convergent sequence, because even though there's two separate things kind of bouncing back and forth going on, they are closing in on a definite end result. If we put in something like 1,000,000 for n, then I think we're getting pretty close to 0, but we can test that out. So let's go back to the original function here. And it was 12 times negative 0.75 to the n minus 1. So I'm just going to put 1,000,000 in there. Let's suppose I used 1,000,001 for n, so it's 1,000,000 when I subtracted 1. I think it's getting pretty close to 0, but let's see. Yeah, it's so close to 0 the calculator can't even tell the difference anymore. So this is converging to a single value eventually. And that's something you'll start to do more with in calculus.